Hello everyone, welcome back to our channel. This is lecture series 16 Embedded C Basic. In this video, we'll be seeing about how to convert a hexadecimal to a decimal value and display those decimal value in different ports like P0, P1 and P2. Come, let's go into the video. Please do like, share, subscribe and comment. So for this, as usual, you will have the register 51.h to map all the libraries of 8051 microcontroller, and then going into your main function, you are going to assign a character of hexadecimal value, that is 0xCF. So now here CF is nothing but your hexadecimal value. Now this hexadecimal value will be converted to decimal, and that decimal will be stored in different ports like P0, P1, P2. So now, how to convert this hexadecimal to decimal? So now here they have given a value, decimal is equal to a by 10, and here decimal divided by 10. So those values, once a is divided by 10, that value will be stored in P0. When decimal is again divided by 10, then it is stored in port 1, and finally the remainder will be stored in P2. So this is how it has been stored. So now you may ask how this B has come, because this B hasn't been initialized anywhere, right? Because for using decimal value, DECI DESI is being initialized, but A or B is not at all initialized. So here the register A and B is already there in your 8051. So when you use assembly level language program, you are going to this A divided by 10 will be represented as div A comma B, where the A value, that is A register, will store the quotient value and B will store the remainder value. How? I will show you now. See here, 0xCF hexadecimal is converted to decimal, that is 16 to the power of 1 into 12, that is C is 12, so 12 into 16 to the power of 1 plus F is 15, 15 into 16 to the power of 0. So 15 is retained same, so 12 into 16, 192, so totally added 192 plus 15, it is 207, which is the decimal value of CF. The hexadecimal value of CF will have the decimal value 207. Now this 207, how it is being placed in different ports? For that, this 207 is divided by 10, because this is stored in a particular register, say A. In that, A is divided by 10. Now you see here, A is divided by 10 to store the P0 value, that is P0 value. So when you divide this by 10, what happens? 20 times it is 200. So 20 will be your quotient, 7 will be your remainder. So this remainder value will be stored in the port 0. So now what happens? So one port 0 value you have got. How to get P1 and P2 value? So for that, what happens? P1 value, again the decimal is divided by 10. What? This 207 is not divided. The quotient what you have got will be again divided by 10. So 20 by 10 is equal to 0 will be your remainder. 2 times, so quotient, 2 will be the quotient. So the value 0 will be the remainder which is stored in the port 1. Now how port 2 value will be stored? So now again this quotient is divided by 10. So 2 divided by 10, 0 will be your quotient, because you cannot divide it, right? It is only 2. So the same 2 will be the remainder and 0 will be the quotient. So finally the value 2 will be stored in P2. So remember 702, P0, P1, P2. Now generally, when you execute in KeiBE software, you are going to debug and execute it and see the result in the watch window, right? Or serial window. Now here, in a different way, you are going to see the output. After debugging, you are going to run the program and then go to the peripherals, select input output ports, select port 0. If you select port 0, then 07 will appear in port 0. See? 7 reminder, so that value will appear in port 0. Again, click input output port, click on port 1, you will have 0 value. So here is your port 1 0 value. And if you again click port 2, then 2 value will be displayed in port 2. So reminder 2 that will be stored in port 2. So after debugging, you have to go to peripheral, click input output ports, and each of the port when you click, you can observe the value stored in that particular port. Hope you have understood this. Please be stay tuned for more information. Thank you.